Sir Isaac Newton, a name synonymous with genius, a figure who reshaped our understanding of the universe. Born in England in 1643, Newton's life was a tapestry of groundbreaking discoveries and profound insights. His work transcended boundaries, influencing physics, mathematics, astronomy, and even our perception of reality itself. Newton's early life was marked by both challenge and solitude. Born prematurely and fatherless, he faced a difficult childhood. His mother remarried, leaving him in the care of his grandmother. This period instilled in him a sense of introspection and a thirst for knowledge. Despite these hardships, Newton's innate curiosity shone through. He possessed a keen interest in the workings of the world around him, spending hours observing nature and tinkering with contraptions. His early experiments, often conducted in the solitude of his own thoughts, hinted at the scientific giant he would become. At the age of 18, Newton entered Trinity College, Cambridge. Here, his intellect flourished under the guidance of esteemed professors and amidst a vibrant academic atmosphere. He immersed himself in the works of great thinkers like Galileo, Kepler, and Descartes, absorbing their ideas and building upon their foundations. Cambridge provided Newton with the intellectual tools and the stimulating environment he needed to truly blossom. It was here that he began to formulate his groundbreaking theories on calculus, optics, and the laws of motion, forever altering the course of scientific history. Perhaps the most famous anecdote about Newton involves an apple and a moment of profound insight. This story has been told for generations, capturing the imagination of many. Legend has it that while contemplating the nature of gravity, Newton was sitting under an apple tree in his garden. Newton witnessed an apple falling from a tree. This seemingly simple event was anything but ordinary to Newton. This seemingly mundane event sparked a cascade of thoughts in his mind, leading him to question why the apple fell straight down and not sideways or upwards. This line of questioning led him to formulate his law of universal gravitation. He began to ponder if the same force that pulled the apple to the ground could extend beyond the orchard. Newton realized that the same force that pulled the apple to the ground was not just a local phenomenon. He theorized that this force also governed the motion of the planets around the sun. This revolutionary idea was groundbreaking. Newton proposed that a force of attraction acts between any two objects with mass, no matter how far apart they are. This provided a unifying explanation for a wide range of physical phenomena, from the falling of an apple to the orbits of celestial bodies. Newton's insight laid the foundation for classical mechanics and changed our understanding of the universe forever. Section 5. Unraveling the Cosmos, Newton's Principia Mathematica. In 1687, Newton published his magnum opus, Philosophiae Naturalis Principia Mathematica. This groundbreaking work, often referred to simply as the Principia, laid out his three laws of motion and the law of universal gravitation. It was a masterpiece that revolutionized our understanding of the universe. The Principia was not merely a collection of theories. It was a comprehensive framework for understanding the physical world. Newton's work provided a mathematical language for describing the motion of objects, from projectiles to planets, and established the foundations for classical mechanics. Section 6. A prism of brilliance, Newton's contributions to optics. Newton's genius extended beyond physics and astronomy. He made significant contributions to the field of optics, particularly in understanding the nature of light. Through his experiments with prisms, he demonstrated that white light is actually a composite of different colors, each with its own unique refractive index. Newton's work in optics led to the development of the reflecting telescope, a revolutionary invention that used mirrors instead of lenses to gather light. This new design allowed for larger and more powerful telescopes, opening up new avenues for astronomical observation. Section 7. Beyond physics, Newton's impact on mathematics. Newton's contributions to mathematics were as profound as his work in physics. His innovative thinking and relentless pursuit of knowledge led to groundbreaking discoveries that have shaped the very foundation of modern mathematics. In his quest to describe the laws of nature with precision, he developed a new branch of mathematics known as calculus. This was not just a minor addition to the field, it was a revolutionary tool that transformed how scientists and mathematicians approached problems involving change and motion. This powerful tool allowed him to analyze motion and change in ways that were previously impossible. Before calculus, the mathematical tools available were insufficient for dealing with the complexities of dynamic systems. Calculus provided a language for describing continuous change, enabling scientists and mathematicians to model a vast array of phenomena. It allowed for the precise calculation of rates of change and the accumulation of quantities, which are essential in fields ranging from physics to engineering. From the orbits of planets, where it helped explain the elliptical paths and gravitational forces at play, to the flow of fluids, where it provided insights into the behavior of liquids and gases under various conditions, calculus became an indispensable tool. Newton's invention of calculus was a testament to his ability to create entirely new mathematical frameworks to solve the problems he encountered in his scientific pursuits. His work laid the groundwork for countless advancements in mathematics and science, influencing generations of thinkers and researchers. Today, the principles of calculus are applied in a multitude of disciplines, from economics to biology, and even in the development of new technologies. Newton's legacy in mathematics is a shining example of how one individual's curiosity and intellect can change the world. Section 8, The Enduring Legacy, Newton's Influence on Modern Science. Sir Isaac Newton's legacy is immeasurable. His work laid the foundation for classical physics and inspired generations of scientists. His laws of motion and gravity continue to be fundamental to our understanding of the universe, underpinning everything from the design of bridges to the exploration of space. Beyond his specific discoveries, Newton's approach to scientific inquiry, characterized by rigorous observation, experimentation, and mathematical analysis, became a model for the scientific method. His emphasis on empirical evidence and logical reasoning helped shape the very way we approach the pursuit of knowledge. Section 9. A Timeless Inspiration, Reflecting on Newton's Genius. As we reflect on the life and work of Sir Isaac Newton, we are reminded of the power of human curiosity. Newton's insatiable quest for knowledge and his relentless pursuit of understanding the natural world have left an indelible mark on science and humanity. His contributions span across various fields, from mathematics to physics and even astronomy, and the transformative potential of a single mind. Newton's ability to think deeply and critically about the world around him led to groundbreaking discoveries that continue to influence our lives today. His work on the laws of motion and universal gravitation laid the foundation for classical mechanics, a cornerstone of modern science. Newton's journey from a solitary child observing the world around him to a young man studying at Cambridge University is a testament to the power of education and intellectual curiosity. His early observations and experiments were the seeds that grew into his later monumental theories. To a scientific titan who reshaped our understanding of the cosmos, Newton's Principia Mathematica, published in 1687, is one of the most important works in the history of science. It not only introduced the laws of motion and universal gravitation, but also provided a new framework for understanding the physical universe, serves as a timeless inspiration to us all. His ability to connect seemingly disparate phenomena under a unified theory exemplifies the power of human intellect and creativity. Newton's work continues to inspire scientists, thinkers, and dreamers around the world. His legacy reminds us to never stop questioning, to embrace the unknown, and to push the boundaries of what we know. Newton's life teaches us that curiosity and perseverance are key to unlocking the mysteries of the universe, and to seek out the hidden connections that bind the universe together. Newton's work on optics, for example, revealed the nature of light and color, showing us that even the most familiar phenomena can hold deep secrets waiting to be uncovered. For it is in this spirit of exploration and discovery that we truly honor the genius of Sir Isaac Newton. His life and work serve as a beacon, guiding us toward a deeper understanding of the world and our place within it. Let us continue to be inspired by his legacy and strive to make our own contributions to the ever-expanding tapestry of human knowledge.